To another exciting day of Algebra 2. Today we are going to be talking about something called completing the square. Now, what square are we talking about? We are talking about a thing called perfect squared trinomials, which are the result of squaring a binomial. So x plus a number squared or x minus a number squared, when we FOIL that binomial and we end up with a trinomial, that is called a perfect square trinomial. So these are some examples below here. And when we're recognizing perfect square trinomials, our first and last terms are always going to be perfect squares and positive, and the middle terms are going to be twice the product of the other two. So how do we complete the square? If I am wanting to make a perfect square trinomial, I'm going to take half of the middle term and square it. And that is how I get my squared binomial, which when I FOIL, I get my trinomial. So let's practice that first. On example set 1, we are just going to make perfect square trinomials. So on part A first, my middle term is 10. If I half 10, that is 5. And 5 squared is 25. So 25 is the term that completes my perfect square trinomial. And if I'm rewriting this as a squared binomial, that second term, x plus blank, that is my half of my middle term. So that is 5, x plus 5 squared. Let's do this again on B. My middle term is 11. Half of 11 is 11 over 2. And if I square that, I square the top and the bottom, that's going to be 121 over 4. So 121 over 4 is the term that completes my square. And what goes in my squared binomial is that half of the middle term, 11 over 2. Okay, again, my middle term on C is negative 12. Half of negative 12 is negative 6. If I square negative 6, I get 36. So that completes my square, and my squared binomial is x minus 6 squared. Last one for this set, I need to find half of negative 6 over 5. That is going to be negative 3 over 5. And if I square that, I get 9 over 25. So 9 over 25 is what completes my square, and I have x minus 3/5 as my squared binomial. Okay, so what do I do if I already have a quadratic and I want to turn it into a perfect square trinomial? Well, what I'm going to do first is move any constants I have to the other side of my equation. So in example set 2, starting with A, I'm going to move the 16 to the right-hand side with subtraction. And now I want to make this a perfect square trinomial. So I'm going to follow the same steps we did on set 1, which is half the middle term. Half of 2 is 1. 1 squared is 1. And if I'm adding 1 on the left, I also need to add 1 on the right. So what I can do is rewrite this as a squared binomial, x plus 1 squared, and that's going to be equal to negative 15. Okay, let's do this again on B. Move my constant to the other side. And I want to make a perfect square trinomial. So half of negative 5 is 5 over 2. 5 over 2 squared is going to be 25 over 4. And if I'm adding it on the left, I need to add it on the right as well. So this is going to be x minus 5 over 2 squared is equal to, and I want to leave this as a fraction, and this is where our calculator is going to come in handy. I can type this into my calculator, 18 plus 25 over 4. And it will give me a decimal, but I can tell my calculator to make it a fraction by saying math, enter, enter, and it'll give me 97 over 4. So that math button is just right here below alpha. Math, enter, enter will turn your decimal into a fraction. So there is my squared binomial equivalent to a number. Let's do this again on C. Move my constant 12 to the other side. I need to half the middle term and square it. Half of negative 10 is negative 5. Negative 5 squared is 25. If I'm adding it on the left, I need to add it on the right. So x minus 5 squared is equal to 13. Last one for this set. Move my constant to the other side. Half of 15 is 15 over 2. 15 over 2 squared is 225 over 4. If I'm adding it on the left, I need to add it on the right. And again, I'm going to use my calculator to add those numbers. Negative 2 plus 225 over 4. Math, enter, enter. 217 over 4. Okay, so why are we doing this? Why do we complete the square? Completing the square is another way that we can solve quadratic equations. Remember, we have factoring, we have the quadratic formula, and we also have the square is a third method. So to solve by completing the square, we're going to do the same steps we've been practicing on that front page. If we have a constant, move it to the other side, add what completes the square to both the left and the right, rewrite it as a squared binomial equal to a number. So we've already done steps 1 through 4. The last two steps, 5 and 6, are just the final icing on the cake, which is to take the square root of both sides and then get x by itself. And that's how we're going to get our solutions. So let's jump right into some examples. Example set 3, starting with A, I'm going to move the 14 to the other side. And I want to complete the square. Half of 8 is 4. 4 squared is 16. So I'm going to add 16 to both sides. This becomes x plus 4 squared equals 2. So again, steps we've already done. Where we get those last two steps that are new, we're just going to take the square root of both sides. So x plus 4 is the plus or negative square root of 2. I cannot simplify that further, so I'm just going to bring the 4 over to get x alone. And so negative 4 plus the square root of 2 or negative 4 minus the square root of 2 are my two solutions. All right, let's do this again on part B. I'm going to move my constant to the other side. I want to complete my square. Half of negative 5 is negative 5 over 2. If I square that, I'm going to get 25 over 4. If I add that to both sides, this is going to become x minus 5 over 2 squared. Again, I'm going to use my calculator to get me a fraction answer. Math, enter, enter, and I get negative 15 over 4. And when I go to take the square root of both sides, I'm taking the square root of a negative, which is a no-no. So this one is going to have no real solution. On to part C, move my constant to the right-hand side. I want to complete the square. Half of 12 is 6. 6 squared is 36, so I add that to both sides. This becomes x plus 6 squared. Negative 27 plus 36 is 9. And 9 is a perfect square, so I'm going to get rational solutions, which means I am going to actually do this plus or minus operation. We're not going to leave it in the answer. I'm going to get my first solution by subtraction. Negative 6 minus 3 is negative 9. And negative 6 plus 3 is negative 3. So there are my two solutions. All right, last one for this page, moving my constant to the other side. Completing the square, half of 9 is 9 over 2. If I square that, it's going to be 81 over 4. So I'm going to add that to both sides. X minus 9 over 2 squared is equal to, I'm going to use my calculator to get a fraction answer. And that is 85 over 4. When I go to take the square root of both sides, I'm going to have x minus 9 over 2 is equal to plus or minus the square root of 85 over 4. Now, if I want to simplify this radical, 85 is not going to simplify, but 4 on the bottom is a perfect square. And when I have a fraction inside my radical, I can actually rewrite it as a radical divided by a radical, and I can reduce my denominator. So this is going to be x minus 9 over 2 equals plus or minus the square root of 85 over 2. And when I move the 9 over 2 over, I can leave this as two separate fractions, or because they have the same denominator, I can rewrite it as a single fraction. Either of those is correct. Okay, on to our last part. Up to this point, all of our quadratics we've been solving have had a being equal to 1. So what do we do when a is bigger than 1? We're going to be following the same steps that we've been doing. However, after we get our constant on the other side, we're just going to divide the entire equation by a. And then from there on out, it's the same steps. Complete the square, rewrite it as a binomial, square root both sides, etc. So let's get into some examples on that. Here is example set 4, starting with part A. I'm going to move the 1 to the other side. And now a is 3, so I'm going to divide everything by 3 and get x squared minus 2x equals negative 1/3. And I'm ready to complete my square. Half of negative 2 is negative 1. Negative 1 squared is 1. So I add that to both sides. And x minus 1 squared equals 2/3. Square root both sides. And I'm going to get that x is 1 plus or minus the square root of 2/3 as my final answer. Okay, on to b, moving my constant over. A is 2 for this equation, so I'm going to divide everything by 2. Now I need to complete the square. Half of 5 over 2 is 5 over 4. If I square that, I get 25 over 16. So I am going to add that to both sides. So x plus 5 over 4 squared equals, let's get a fraction, 4 plus 25 over 16. That is going to be 89 over 16. Square root both sides. And again, 89 can't be simplified, but 16 can. So I'm going to have x plus 5 over 4 equals plus or minus the square root of 89 over 4. Move the 5 over 4 to the other side. And again, I can leave this as two separate fractions, or I can make them a single fraction because they have the same denominator. All right, last two. Example C, all of my equation is kind of rearranged here, so I'm going to move the 24x over and move the 42 over. A is 3 here, so everything gets divided by 3. I'm going to have some nice whole numbers here, and that should be 24x. I don't know where my head is at. All right, completing the square, half of 8 is 4, 4 squared is 16, so I'm going to add 16 to both sides. And x plus 4 squared is going to be 2. Square root both sides. Move my 4 over. And I have negative 4 plus or minus the square root of 2. All right, last but not least, I'm going to move my constant. A is 5 for this equation. So x squared plus 12x equals negative 20. Completing the square, half of 12 is 6. 6 squared is 36, so I add that to both sides. And I have another perfect square, so I'm going to get rational solutions, which are whole numbers. So that's going to be negative 6 minus the square root, or excuse me, 4, which is 10, and negative 6 plus 4, which is negative 2. And that concludes our notes on completing the square.